Alright, now we're going to do a question on vectors. The focus of this question actually is to show the example of how to approach questions that are similar to this pattern, where they say two vectors are actually parallel and you have an unknown in there. Okay, so the first two parts A and B actually basically are just finding certain column vectors as a single vector. So for example, 3p plus 2q, basically taking 3 times of vector p, which is 3, negative 6, and I add 2 times of q, negative 2, 5. So we can do this in terms of mental calculation. Basically I have 9 plus minus 4, or negative 4, and then below I have negative 18, and I add 10 to it. So the sum of that simply is 5, negative 8. So that's a single vector for part A. Same thing for part B, 4p minus q. Basically is 4 times of p, 3, negative 6. Let's subtract away q from it. All we get is actually 12 plus 2 and negative 24 minus 5. And that will give us a single vector simplifying to 14, negative 29. Right now, so they say that if vectors p and r are parallel, okay, meaning vector p is parallel to vector r, find the value of m. So the moment you see these two being parallel to each other, we can immediately say that p is k times of r in terms of vectors. We'll write it down, p, 3 minus 6, and r, m, 4. Okay, I left this out. K basically is some value. Alright, so what we're doing here now to find m is to actually do by comparison, the top and the bottom, and eventually find k to find m. So I'm going to compare the bottom first. Implies that negative 6 actually is to 4 times of k. So what exactly is the value of k? If I divide it, negative 6 divided by 4, I'll actually get negative 1.5. So what does it mean then? Once I know k, then I actually can now compare the top, which means that 3 is equals to negative 1.5, which is k, times m. So therefore, what is m? M is the value of 3 divided by negative 1.5, which gives me minus 2. So therefore, I can now rewrite r fully, the vector, as negative 1.5, 4. Right, so that's the first part. And now on to the second part. Find the ratio of p to r in terms of vectors. So now if I compare p and r, 3, negative 6, first of all, p is this, and r is this. Oh wait, I made a mistake here. It's minus 2 here. So it should be negative 2. Alright. Notice that actually when I compare the two, they seem to be multiples of each other. Or rather, they share some common numbers in between them. For example, if I take out the scalar of 3, or factor of 3, I'll have 1, negative 2 left behind. And if for r, I take out the scalar value of 2, I'll actually get negative 1, 2. Now look, these two are actually parallel vectors. So in terms of magnitude, basically p is to r is the ratio of, as you can see, 3 is to 2. That's it.